In the course of evolution, the ancestors of elephants living in tropical environments really had to face the challenge of how to keep cool.
The elephant's skin evolved to enable a process that works just like a car's engine cooling system to beat the heat. Elephant ears, like two living car radiators, are built thin, stretched over cartilage packed full of blood vessels. And just like coolant arriving hot from the engine, hot blood circulates from the elephant's body into its ears, where it is cooled by its proximity to the open air. Ear flapping kicks up a breeze and boosts the cooling effect like a radiator's fan. And the elephant's blood, cooled by up to 10 degrees, is kept from overheating in the blistering sun. Frequent baths of water and mud help too. With heating and cooling systems in place, mammals are able to spread out over all 7 continents. But this isn't the only secret to the mammal's success. Skin in females goes through another remarkable transformation.
Without skin, we wouldn't have had mammary glands.
Female mammals develop the ability to lactate, passing nutrition to their young through skin.
Hey, buddy.
Biologist Katherine Hind studies lactation and its role in survival and behavior in a managed population of rhesus macaques on Cayo Santiago Island in Puerto Rico.
Rhesus macaques, like the ones on Cayo Santiago, typically nurse from 6 months up to about a year.
Mother's milk, delivered through the mammary gland, greatly improves the chances of a baby's survival by providing nutrients and antibodies that protect against diseases. The evolutionary roots of breastfeeding go back over 300 million years to the time of the strange reptilian creatures called synapsids, ancestors of mammals, and us, who laid eggs rather than carried their young.
Synapsids, 310 million years ago, evolved a mechanism for expressing fluids through their sweat glands that kept eggs moist.
Over subsequent millennia, the fluid that simply dripped from the skin like sweat grew richer and richer in nutrients. Today, there are only 3 species of egg-laying mammals called monotremes. The best known is the platypus, which, like the synapsids, lactates through pores in the skin. The skin has turned sweat into food.
The fact that modified sweat glands turn out to be milk-producing glands that actually feed mammalian young. This is a superb example of evolution.
In another lineage of mammals, mammals' milk grew richer, the delivery system more elaborate, until the familiar and successful combination of nutritious milk, breasts, and nipples was in place in almost every female mammal. Why do males have nipples? They develop in the embryo before gender is determined and remain ever after. Male nipples may be a useless adaptation, but for mammals, the female breast remains vital for survival.
The most important aspect of maternal care is lactation.
And Katherine Hind has learned that macaques use the time they are dependent on their mothers to learn vital lessons that could make the difference between life and death.
Mother's milk allows infants to learn about the world in which they're going to have to be adults while still being energetically protected by their mother. So while they get milk, they're able to learn how to process food, learn how to socially interact, and develop all the skills that they'll need in a complicated adult world.
The socialization encouraged by skin's evolution of breasts would blossom with the mammals that emerged close to 2 million years ago. Human beings. But humans did not retain skin like macaques. A new kind of skin evolved, unique among primates.
Humans have really different skin from any other creature.
All of of a sudden, we have a very different kind of animal in equatorial Africa. Not an ape sitting or scurrying around near the shelter of trees, but an active striding biped spending a lot of its time in open, hot environments.
The lion's coat, the gorilla's fur, none of it would be of use to humans. We needed to get naked, and we needed to keep cool. Humans were on the run, out of Africa and straight to the top of the food chain. Scientists now believe that what made it possible was a single evolutionary mutation in human skin.
It's the ultimate story of survival.
How did humans come to dominate all other mammals? Could the answer lie in the way the human skin evolves?
Humans have really different skin from any other creature.
Human skin is, of course, a barrier to the outside world. It protects our insides and is by far the largest organ in the human body. It is responsible for 1/6 of our body weight. In other words, if a 160-pound man were able to step out of his skin, he would lose more than 26 pounds.
It's hard to find important function in the body that skin doesn't have a role in.
Human skin, like all skin of animals with spines, is made up of 2 distinctive layers. The top one replacing itself completely over the course of 28 days, shedding 500,000 cells an hour. This churning mix of dead and live cells seals out water, dust, and germs.
It is a very, very specialized, unusual organ that is simple but deceptively complex.
Dan Lieberman is a professor of biological anthropology at Harvard University.
I study the evolution of the human body. I'm interested in why the body looks the way it does and how it got to be that way. Humans are most closely related to chimpanzees, and we know that the human and the chimpanzee lineages diverged sometime around 6 to 7 million years ago.
The last common ancestors to chimps and humans, hominids, lived in the tropical climates of Africa. They looked like chimpanzees, walking on all fours and covered in hair.
Sometime around 6 million years ago, hominids got up on 2 feet and became bipedal. And for millions of years, the earliest hominids were sort of bipedal chimps in a way.
Being able to stand upright and walk is only part of the human evolution story. As humans begin spreading out across continents, something else proves to be critical in the quest for domination: the ability to run.
The human lineage became more active, and they increased in stature and their levels of activity. Different physiological needs became apparent.
But what enables humans to be able to run in the first place? The answer lies with skin. Dan Lieberman and his team at Harvard examined why and how human beings evolved to run. And they believe the evolution of our skin played a big role in that change. Lieberman and his team demonstrate that at least 27 anatomical features on the human body evolved solely for running. To them, that is clear evidence that running is an extremely important part of what gave humans a big advantage. Most pronounced among these features, our large gluteus maximus, better known as the butt.
Humans have an enormous gluteus maximus. It's the largest muscle in the human body. If you were to look at a chimpanzee's rear end, you'd see it was very small, very, very pathetic. So, are you ready? I'm recording. When our subject was on the treadmill walking, you saw that not much is happening. She's not really sweating very much, and her trunk is very stable, and her gluteus maximus isn't firing very much. But when she starts running, she's falling. Every time she hits the ground, her body wants to fall forward. There go the gluteus maximi.
The powerful glutes kick into gear when we run to keep us from falling over, stabilizing the trunk and legs. For 4 million years, the ancestors of humans walked on 2 legs, and yet they didn't advance much beyond being bipedal apes. So walking is not what transforms the hominid body, but according to Lieberman, running could be.
It's still a mystery, of course, as to why humans became furless and sweaty, why we became naked. But we think, at least I think, that it happened because of thermoregulation and running.
Evolving features to run is not enough. The hominid body needed something else, a cooling system. Mammal skin had evolved hair to keep them warm in cold climates. Early hominids in Africa have the opposite problem. They need to be able to keep their bodies and brains from overheating. Ever able to adapt, the skin of humans and other mammals living in hot climates simply stop producing so much hair.
We have, compared to other mammals particularly, we have skin that is got almost no hair.
Human skin would evolve to supply its own cooling bath in the form of sweat.